All right, good evening, ladies and gentlemen. Today we're having a team up with Edmonton Python Meetup, so I'm really excited to try out this new software and everything seems working fine. So as probably you are first time using this software as I do, when you first join, you can join two different tables. So feel free to turn on your mic and camera to talk to the people on your table. So it's more like a chat room or something like that. And then, mingle around, make introductions and that stuff. And yeah, once the meetup actually begins, just like right now, it's going to broadcast to all the tables and everyone can see me, hopefully. So yeah, here we go. So we're having a joint meetup this month and probably in the future as well. And here we have our Slack as the PyYYC design Slack, and EdmontonPy also have their Slack as the dev@edmonton.slack.com. They also have Twitter and website, so feel free to check it out. And I would also like to thank to our long-term collaboration partner, Teammate. So Teammate is a agency firm looking to hire the best of all. And yeah, Rich, do you want to say something, or that's good?
Yeah, just finding the remote. Yeah, so I work for Teamit, and yeah, basically what we've been doing for a while is recruiting remote-based teams. Which first we used to be industry leaders, but now remote is the norm. So if anyone has any questions about working remotely, we work with companies across Western Canada and the U.S. Just shoot me a note afterwards, or connect with me on LinkedIn anytime. Thanks.
Cool, awesome. So next, I would like to thank Startup Edmonton and Edmonton Python Meetup to hosting this meetup for us and allowing us to use this remote platform. It's a really exciting experience for me, and I think it'll be very good for all of our members. So yeah, and if you want to collaborate in the future for any kind of collaborations, feel free to let me know or let Rich know. There are a couple of jobs I would like to introduce. So the first one is a senior full stack developer, and another one is a backend developer. So these links are clickable. I guess I should share that later. So I will actually share the link to my opening slides in the general chat. So keep an eye there. So we have two tasks today. The first one is why should I trust you? Use SHAP for interpretable AI by Chris. And the second one is Streamlit and Panel, building web apps in Python for data analysis by Michael and Anton. I'm really excited to see them. We have a few upcoming events. The first one is a PyCon, and it's May 12th. And the next one is DjangoCon. And also there are a lot of wonderful events here in this link, so feel free to check it out. And nowadays it's all online, so it'll be pretty easy to access. There are some news. So the first one is we have an early developer preview of Python 3.10. And the Python 3.9.4 hotfix is now available. The Python Software Foundation, which is called the PSF, is hiring a package PM developer and a developer for CSON. And the Django debug toolbar security release has been issued. So if you are using that, make sure you have that updated. Django 3.2 was released, and we're actually using that, and it's pretty great. And the last one is the Django Technical Board candidate registration is open. So if you want to become a board of members of Django, feel free to register there. Yeah, the reading for the month. So the first one is an alternative to Python dictionaries, which is the default dict. So this one is really, really easy to use. Basically, when you are using that, you don't have to do the if else to check if the key exists. It automatically gives you the key. So I basically use that all the time. The second one is the 8 built-in functions every Python programmer should know, which are the hash, map, zip, eval, split, ord, dir, and power. Basically, hash, it's just hashes. Map maps two things together. Zip also zips two things. Eval evaluates certain stuff. Split is mainly used for string. Ord can change convert a string to its ASCII value, which is integer. And the dir can print out all the dunder methods and methods for this function or class. And power give it power. So definitely check it out. Very handy functions. Next one is why Python is slow, looking under the hood. So this article is really, really nice. It's a pretty long but detailed article explaining why Python is slow. Essentially, it's a type checking for each line of code because Python, is a language of object-oriented language. So pretty much everything is object, and every line needs to check object type, so that's why it's slow. But this article explained much better than what I did, so definitely check it out. The last one is 3 seemingly simple Python features that confuses beginners. Well, yeah, these are pretty confusing, even for more senior people. So definitely take a look. The logical operators, assignment expressions, and context managers. If like it's really easy and tricky. It's really easy to make mistakes there and tricky to debug. So yeah. And at last, here at the top, they are the stats website you want to check out. And the next meetup is May 26th. So look for further notifications on the details for that. And we're always looking for presenters, both the PyYYC and EdmontonPy. So for PyYYC, feel free to select me in the YYC Slack channel. And for Edmonton Python meetup, feel free to select these 3 wonderful people on the Edmonton Slack channel. So how tonight's going to work is that we're going to first have Chris to present his topic, and then we will have the second presenting topic. And after that, I will do a PyCharm license draw for 2 people. So we have 2 chances. Feel free to stay around, and I will do a live draw there. And after that, feel free to mingle around, in tables, and hopefully you all have fun tonight. All right. So I'm going to post the draw spreadsheet in the general channel. So I'm going to do that right now. If you can see that, you can click that and put your name in the column. And if you want to participate in the draw, and I will do a draw, 2 draws later. Next, I will give it to Chris.
Okay, all right. Thank you, Carson. Can everyone hear me okay?
Yep.
Okay, cool. Yeah. Thank you for joining me today for this talk. So my name is Chen. So I'm currently a senior data scientist at Microsoft and working on cybersecurity problems. And prior to Microsoft, I've been working for many years in energy and telecommunication industry. And I'm also computation master at Kaggle, which is the world's largest data science computation platform. So yeah, this is pretty much about me. And today I'll be sharing some of my experience in how to interpret machine learning models to some non-technical audience. But before I kick off, so I just wanted to ask 2 quick questions, and I don't know how can we do the poll or census, but yeah, so you don't have to raise your hand or write your answer. Just yeah, so it's more like a roll through a question to you guys. So how many of you are actually data scientists, and how many of you are considering to transit into to start a career in data science? And if any of your answer is yes to those two questions, you have been, I bet you probably in the past have been asked very simple questions. Can you explain how the model you develop works? And this may sound and simple and easy question, and pretty sure you probably would have your magic 3 sentences to explain machine learning model to the non-technical users. But essentially, so this becomes a very interesting topic. You will probably ask the again and again and again. And why this is important? It was because it's just because so when people are asking, how does your model work? They're actually not particularly interested in the mechanics or theory of the model. And essentially, they're trying to ask, the question they're trying to ask is, why should I trust you? And if you cannot explain your model very well, so why should I trust you? And this could become very interesting. Okay, so imagine, I will get started using a quick example. So imagine you're a data scientist and you are working for a company ABC, and you are asked to develop a customer Chen model. And the model should be able to take a lot of features and make predictions on which customers are more likely to discontinue the services or unsubscribe their services. And so in order to do that, you followed up all the great best practices, all the way from interviewing the business SMEs and the data gurus, and you find out where the data needed is, and you created a data pipeline and cleaned up the data, trained your model, and evaluated your model. Then you find your champion. So 100 deep neural networks, and which yielded the best evaluation results on the tested stuff. Okay, so then at this point you're very excited. You shared the model performance with your boss, and everybody on the team are happy as well. So, and then you decided to take the model and make predictions on the customers, and it turns out so the model did a great job to take the data you wanted to use and make predictions for every single customers in the database, and assign them with a probability of churn, and therefore you come up with a whole list of risky customers the model believed to be, and at this time, so let's hold on a second. So this is a very typical process for machine learning model development. And if you take a look at any textbook and any best practice, and say if you went to any the presentation from the vendors, they would probably be telling you the same story to follow up the similar process. But let's pause here and really think about what else can we do to gain the trust, and what could be wrong in this process. In order to answer the question, so while you are thinking, so in order to through the question, let's take a look at the scenario and what could possibly happen. And in fact, this is a real story happened to me. So you took the model and you talked to the business owners, and they wanted to start using the model to to return the customers plated as risky. And at this point in time, so the model is able to answer two questions: which customers are going to churn, and how likely they are going to churn based on the probability of churn, right? And So you're pretty happy, and and think, okay, so this should be working. But when you handed over the model to the business, to those who will be actually doing the job to save the customers, so what they ended up in their hands are just a list of names, and along with some code digits to indicate the probability of Chen. And as a human being, so everybody, and we are human beings, and we are naturally curious about knowing something on the mechanisms and how does it work under the hood. And if I were provided with just a list of customers and the probability, and I would start to wonder, I would start questioning how does it work, and why should I trust you, right? And the problem is, so by only providing the probability and only probability providing the names, so there, you are not providing the context, and you're not answering the questions how or why they are going to train. And eventually that becomes the questions we talked about, why should I trust you? And if we couldn't do a good job at answering the questions, you will have a problem. So let's take a look at this. So and we definitely need to be able to interpret the model, but in order to interpret the model, so the most natural way is to, okay, let's explain how the model is working. So remember, so the model you developed is a multi-layer perception, right? And they start trying to explain the concept to the non-technical audience, and it started by, okay, so it's a neural networks. It comes with multiple layers, and each layer there are neurons, and each neuron connects to the previous and the next previous neurons, and the neurons in the next layer. And essentially, so if I threw in data into the neural network, and the neural network automatically calculated the weights, which is represented as the edge in the neural network. And yes, by the end of the day, the model should be able to learn to tell which customer is going to train and which are not. So this is a very typical way of explaining neural network, but it doesn't answer the fundamental questions: how the model sees the input and connects and correlates them with the output, which is the predicted probability of Chen. Essentially, so if we were able to come up with something simple yet effective to be able to take the input and explain how each input variable contributes to the final results, which is the probability of Chen. So would this work? And if this is going to work, would this be something we should be pursuing? Would that be the silver bullet to answering the question, how does the model work? And that's essentially what I'm going to cover today. So here I'm just quoting the statement from the Miller team, who's the author of the book Explanation in Artificial Intelligence. So in the book, he said, interpretability is a degree to which a human can understand the cause of a decision. So if we can understand the cause of a decision, it means, so even though I probably still didn't quite understand how neural network is working. So, but I started realizing, okay, what the model does makes sense to me, and therefore I would start having some trust into the model. So being able to interpret the machine learning model has many benefits, and one of the benefits we've talked about is so to explain how the model works, and also understand some edge cases. And so here I'm just using the very popular dataset, which is called the MNIST. It consists of many handwritten digits, and in the format of images. And so it consists of the digits from 0 to 10. And here I'm just showing interpretation from the package I'm going to talk about today, which is called SHAP. And this diagram demonstrates how SHAP sees the images and make it interpretation. Basically, so if you take a look at the color, so if you take a look at the color, so the red means the model sees the pixels contributes to the corresponding classes. But if you see blue, and it means so the model says okay, so that makes a negative contribution to the classification result. So what does that mean? So it may sound confusing, but if I wanted to give you a concrete example. If you take a look at the bottom row, on the left is the digit 4, and on the right hand side you would see 10 copy of the image of the 4, but falling into corresponding classes starting from 0 to 9. And specifically, if you count 1, 2, 3, 4, 5, the fifth image, the fifth position is actually indicating the classes 4, so which comes with a lot of reds, right? Red pixels, which means from the picture, from the original picture on the left, the bottom left column, so the SHAP model finds a lot of pixels that can be used that contributed to the decision to say, okay, this image is 4. So it sees a lot of reds. But if we take a look at the image on the top right, the far end, on the right hand side, so you would see some blue dots on the top, right? And which means so the model, SHAP's model, sees the image could also be 9 if there are some blue dots on the top. And if because the original image, it doesn't have any pixels on the black pixels on the top, so therefore the model sees it as 9. However, if there are some dots, the pixels are marked as black on the top of the image, so the model, the SHAP, could have identified it as 9 because of those dots. They add some, some negative contribution to the model. So this helps us to sort of understand how a machine learning model sees the image and make the decision. And if we could make sense, for someone who doesn't have a lot of technical background, if we can explain the concept to them, so I think that eventually we are able to. It means we are able to explain the model and explain how does it work. Another use case is it will help us troubleshoot the model and identify the model biases or data biases. So in the world of in the era of big data, so the popularity of the recent popularity of machine learning can greatly attribute to the large volume of the data. But keep in mind that the world is full of noises and biases. And if we train the model with the noise of the data and the bias of the data, we could intentionally introduce the noises and the biases into the model we wanted to use, and which is definitely undesirable. So let me show you a quick example to explain how does it work. So in this image, I'm just showing some, so the computer vision algorithm doing a task called object detection. So basically, it sees the picture and trying to find out the objects in the images and create and draw some boundary boxes for each on top of each object. So in these images, you probably say, okay, so the model does a great job because it's able to find a lot of cards and correctly, sort of join the boundary box for each object. But let me say, what if there's a car and the car is carrying a ladder and is driving on the street? And what if the model still says that it still draws the boundary along with the original car, and without extending the boxes to the boundary of a ladder? So this could be problematic, right? So just think, so if you are developing the self-driving algorithm, and the car wants to pass the previous car, the car in front of it, so it would end up with some potentially incidents, right? So, but in this way, so if we could leverage if we were able to interpret the data and doing some visual troubleshooting, and that would definitely be of help, and being able to help us identify the potential bias before we start using the actual model. The last one is so being able to interpret a model will gain trust from the business. And currently there are many organizations running on their business decisions based on machine learning models. But as a customer, so if I am using some applications provided by some organization, and the organization is not able to answer the why, how does it work, I wouldn't give it a trust. For instance, if I am going to apply for a credit card and I got declined, and the decision was made by some machine learning algorithm, I probably wanted to challenge the decision by asking, so why you think I not qualify for the eligible for the credit card? And if the organization is not able to provide the certified answer, so they could be in trouble, right? And also there are some legal regulations such as the GDPR in Europe, and which requires the machine learning models to be able to interpret its results. So together, so I just wanted to emphasize the importance of being able to interpret the machine learning models. So here I'm just showing some arbitrary some of my arbitrary understanding about the interpretability versus accuracy, and trying how, and hopefully this can help you guide, as it can serve as a guidance to help you understand the so the interpretability and the accuracy for some of the popular algorithm. So when we are developing the machine learning model, we are not only thinking about the accuracy, we are also thinking about the interpretability. So for instance, so neural network and some tree-based model and simple tree-based model like XGBoost random forest, they worked very well in the sense of accuracy, but they are less interpretable as compared to some simple algorithm such as naive Bayesian and logistic regression or linear regression. These algorithms, so they probably don't have the close accuracy as compared to the advanced algorithm, but they are easy to interpret. And in that case, so some organizations would still prefer to use the simple but interpretable model instead of complicated but black box models. So that's the accuracy and the interpretability trade-off that every single designer should bear in mind when they are developing the machine learning models. But what I'm going to talk next is some kind of a model agnostic way to help us interpret the model. I'll be covering it in a later slide. But in this slide, I just wanted to give a quick introduction of some effective way and a more traditional way of interpreting the model. I start with feature importance. And the feature importance is a very effective and powerful tool for the scientists to explain the model. And it depends on the algorithm so you are using and you choose to use. And for instance, linear regression can interpret the feature importance by the scale of the coefficient for each individual features. And the random forest and XGBoost and YGB, those ensemble tree-based machine learning models, they are able to interpret the importance by in the sense of how many times they contributed to the tree splits or they contributed to the the information gain. But the caveat of this approach, the feature importance approach, is it only works and it can only show global importance. What does that mean? So it tells you from the data you use to train the machine learning model, which feature are more important, are relatively more important than others. But if we wanted to take a specific example, a specific instance, and ask how does the model interpret, takes a look at the input variable and check down the values and make the predictions. The feature important analysis doesn't work. It's not able to give you give answers to that kind of a question. Another useful tool is called the partial dependence plot. And so don't get confused by name. So basically it shows, it plots the correlation between the feature in interest versus the target variable. So here I'm just showing an example of a customer Chen sets available online, and just to show the correlation between the dependence between the one of the variable, which is age, versus the target variable, which is the whether or not the customer Chen. So yeah, so and this kind of visualization is helpful in the sense that it's able to demonstrate the correlation between one variable and the target variable. So from the visualization, we clearly see there's a linear correlation between the age and the probability for the customer to disconnect the services for a company, and because of the slope. Another trend, another way is another way to interpret the machine learning model is sometimes we call it using machine learning to interpret the machine learning, and but it has a formal name called surrogate model. And one of the most recent development in this space is called LIME. And basically, the idea of a surrogate model is to train a surrogate model, and which typically would be RAGE, which is a variant of linear regression. And so you choose a subset of feature of interest, and for which you wanted to use to interpret the model. Then you train a small set of for any given instance. You just the algorithm, for instance, the LIME algorithm will try to find the similar examples as to the given in the given instance, and using the those similar examples to train a linear model, and using the trained linear model to interpret how the actual machine learning model sees the data and tries to make the prediction. So this is called surrogate model. So, and this approach have been used by the data science community for a long time. So, well, so NIME is relatively new, but still, so they are considered as so the most common ways to interpret machine learning models. And what I'm going to introduce next is something called algorithm called SHAP, and stands for Shapley Additive Explanation. So it's a unified approach to explain any machine learning model. It doesn't matter it's a DNN, it's an attributes or linear regression. So, and it has a model agnostic way to explain any machine learning model. But for some specific model, for like the deep learning and tree or kernel-based algorithms, so they do have the SHAP comes with a corresponding comes with a specific algorithm to be more effectively to interpret those machine learning models. And the core idea of SHAP is based on Shapley value formed game theory, which was introduced by Noy and Shapley in 1951, and a long time ago. But this idea is so great, and SHAP brought the idea from Shapley and gracefully leverages the idea of Shapley value to answer the question. To answer the question, how does the machine learning model works? And it's possible the model agnostic and the model specific approximation. So that's another benefits. And so yeah, that's the quick introduction of SHAP. But I want to spend a little bit more time on explaining the Shapley what is the Shapley values and how does it work. So basically, the Shapley value tries to the introduction. The motivation of a Shapley value is to answer the question that, so how can we fairly distribute the outcome based on the contribution? So what does that mean? So let's take a look at a quick example. So, and by the way, so I borrowed the example and the images from the online book, which is showing on the link was showing on the bottom. So the name is Interpretable Machine Learning Books. This book is awesome, and I highly recommend everyone to take a look at to read the online book. It's free, and it's one of the greatest books in this area. So in the book, so the author uses very good examples to explain the Shapley value, and I'll try to do my best to explain the similar ideas again. So imagine, so you're trying to, so let's take a look at the house. Now, imagine you've already trained the machine learning model, and then the machine learning model is able to make predictions on property prices. And for a specific apartment, the model, this apartment is predicted worth $300K, and it from the feature perspective, so it has an area of 50 square meter, and is located on second floor, and has a park nearby, and the cats are banned, so it doesn't allow cat to live in. So you may start wondering, how does each feature contribute to the final price of 300K European dollars? So this is how what Shapley value tries to answer. So let's take a very simple example which will help us to understand how fairly estimate the contribution of the feature of a cat being banned. So we take a look at, we find that we take a look at the two properties, and one comes with and both properties have the same features of park nearby and 50 square meter foot, and they are both on the first floor. And it's the only difference is that one doesn't allow cat and another allows cat. And you can see so you can see there's a difference in terms of the price. And if we did the comparison, we can probably say, okay, so in these two specific cases, the allowing cat contributes to 10K euro dollar in terms of value, because the only difference we can tell between the two property is one allows cat and another doesn't allow. So, and we calculate the difference of the difference of the price and interpreted as the contribution of allowing cat. So this is how we calculated the contribution. But in fact, there are not just only two properties, right? There are many possible combinations of the features. So therefore, in order to fairly answer what is the fair contribution from cat band, the feature of cat band should be the average of all the marginal contribution of all possible collisions. So what does collision mean? The collision just means the possible combinations. In the images on the right hand side, so I'm just showing 4 collisions, right? One is the first one is this nothing. The features are irrelevant, and the second one says, okay, so for those houses, for those house properties close to park, and the size are 50 meters, and they are all on second floors. And the third collision is okay, so they are on so for properties with close to the park and 50 meters, 50 square meters. All the properties close to the park, but they are on second floor, and you just etc. etc. So it repeated it just listed all the possible combinations, and they calculated for each combination, each possible collision, calculated the properties prices with that allow cat, and calculated the properties prices that doesn't allow cat, and calculate difference. And we just exhaust the other possible collisions, and therefore we could calculate the average marginal contribution of all possible collision, and that is the SHAP value. And after the process, we should be able to tell that for the feature cat band, how much does it contribute to estimation of property prices, or in another word, so what is the SHAP value of a cat band, the feature of a cat band? So that's how SHAP value works. So the SHAP borrows the idea of SHAP values and tries to assign the SHAP value for every single feature of every single instance in the dataset, and tries to make sense of it. So, and it has a lot of benefits. And the first benefit is it provides a better way for a better way of global feature importance. So I would like to do a quick comparison between the way SHAP interprets the global feature importance versus the way XGBoost, which is the popular machine learning algorithm, does for the same task. So here I'm just showing feature importance diagram generated from by XGBoost. So the importance is calculated as the number of times the underlying feature is involved in a tree split. And it only shows the relatively important, but this doesn't tell if the contribution to the target is positive or negative. So we know it's bad. For instance, we know age is important, but we don't know if age contributes positively, contributes to the customer churn, or negatively contributes to the customer churns. And the third thing is that it only shows the global importance again. So it doesn't tell. It's not able to tell for a given instance that how does the model interpret it, how does the model make the predictions. So as a comparison here, I'm just showing the how SHAP does the same job in terms of feature importance. And I did it using exactly the same data sets and exactly the same model. But instead of using the integrated, embedded feature importance calculation from XGBoost, I used I let SHAP to make the prediction, or to make the interpretation. So how can we read this diagram? I started from the horizontal axis. So the horizontal axis shows the SHAP value, which is the impact on model output, or in other words, the contribution to the output, which is in our case is the probability of churn for a given customer. So positive Shapley value means it adds up to the target. It adds up to the output of the model or the predictions on top of the base value. And the base value is the mean of the Shapley values of all the samples. And the simple way to think about the base value is the average probability of the population, right? So if we are taking a look at the churn problems, the average churn rate can range from 10% to even so 0.1%, depending on the problems, the industry and the specific context. But it's relatively small. So, and if we take a look at randomly take a look at the customer, so the probability for the customer to churn is very small. And here, and let's just assume, so the average the probability is 0.1. And if we take a look at any example, any instance, and take a look at the probability predicted by the machine learning model. So the SHAP value tells how much the specific model contributes to the final prediction. So that's what's showing on the horizontal axis. And the vertical axis, on the vertical axis, you can find all the features, and the features are ranked by the total, the scale of the Shapley values, and but in the meantime, so it also shows the feature values. The color of the diagram also uses color to indicate the value for the value on a specific feature. So what does that mean? So let's take a look at the first feature, which is age. And in that case, So we can see there are a lot of red dots on the right-hand side and a lot of blue dots on the left-hand side. And on the right-hand side, which means there are the instances, they are on average they are more risky than the average the customer, than random customers. And the points on the left-hand side, they are the less risky customers. They are the less risky customers. And the color indicates their age. So because on the right-hand side, there are more red dots, and which means for those customers, the model believed to be risky, they typically are older than the customers on the left-hand side, which are believed to be less risky by the model. Or in other words, the model believes the age plays an important role in identifying whether a customer is risky, is under the risky to disconnect the services or not. And the model believes that the age, the older the customer is, so the more likely the customer could disconnect their services. This is how we can interpret the feature importance diagram from SHAP. And another benefit is the SHAP itself is a sort of a Vining plot, so you can see the distribution. You can see this. Use that to see the distribution across the SHAP values. Another benefit of using SHAP is it provides a better way to describe the correlation between the feature of interest. This is the target. Here I'm just comparing the naive partial dependence plot generated by Cyclone, and it tells that it tells the consistent story that the older a customer is, the more risky the customer is because of the high probability showing on the horizontal axis on the left hand side. But in the meantime, SHAP is able to tell story, but much better. So using SHAP, so you find, okay, so yeah, it is true that as the age becomes, the age increases, the risk also increases because of because the SHAP value can be interpreted as the contribution to customer Chen. And so if we see a loop, the slope, so we probably say, okay, so the older the customer is, the more risky, the riskier the customer is. But in the meantime, so SHAP identifies, okay, so after 60 years, so and the risk of disconnected services are actually dropping, right? So that's one thing. But another benefit is so we can overlay two features. We can play around the interactions between two features, and this is the target variable. In this case, so this diagram also shows also plots the value of whether or not the customer is an active member. So you can see there are clearly two patterns: being active member showing as the red dots, and not active members showing as the blue dots. And typically, generally speaking, being an active member, and regardless of the age, right? So, well, I should be careful saying. So, generally speaking, the being active member reduces the risk to for a customer Chen, just because of the difference between the blue dots and the red dots. But that's not always. So for people who are older than 50 years old. So yes, being in the active member, so does help. But for people who are younger than 40 years old, so that tells the different story. Being an active member actually doesn't really help. Doesn't really help. So, and the diagram that is able to tell us a very very interesting story. So yeah, so SHAP does a better job in terms of creating the dependence plot. And another, and the last but not least interesting feature of SHAP is it's able to provide instance level model interpretation. So this is really interesting, and I was really excited at this the first time when for the first time that I saw it. I thought, wow, oh my god, this helps a lot, and I can immediately see a lot of use cases. So I'm going to use an example to show how it helps interpret the model. So this diagram shows the interpretation from SHAP on how the attributes model makes predictions, taking the input variables and making the final predictions. I'll start with the from the bottom. So on the bottom, so you see a value of 0.184. That is the baseline. That is baseline. Or in other words, so that is the average probability of Chen for the based on the data used to train the model. So on average, a random customer could have 0.18 chance to disconnect their services. So that's the base value. And what the model predicts is for this specific user, the model predicts its probability of Chen as 0.6. But how does this the value of 0.6 is from? So it's based on the other features. The other features, the connectivity, make contribution, regardless it's positive or negative. Connectivity, they contribute to the final decision. They contribute to the final decision. And specifically, this diagram says, this diagram tells is that, so for the feature is active member, so this customer is an active member, it being an active member, the probability of Chen decreased by, sorry, I should, the number was colorful, the decreased by 0.56. So being an active member actually reduced the risk of risk Chen. But the age, this customer is 51 years old, and it adds up to it has a contributed of 0.38 to the probability of Chen on top of the base value of 0.1836, and etc. And if we add up all the contributions on the top of the base value, so it will equal to 0.6. And this is how the SHAP algorithm helps interpret a trained XGBoost model. So how powerful it would be if we were able to bring it along with the the actual machine learning model, classification model, and wrap it up as a heuristic solution and product, and deliver it to the end user. And therefore, it will not only answer the questions which customers are going to churn and how likely they are going to churn, but it will also provide the context and additional information on how the model sees the data and makes the predictions for any given customer. And if we were able to do that, so we actually be able to answer the question, how does the model work? And therefore, we should be able to gain the business trust. And that's essentially the story I would like to share with you guys today. Well, so by the way, so on the top and on the bottoms, I'm just showing another alternative visualization, which is essentially the equivalent of the diagram on the left hand side. It's just my preference is the one on the left hand side. But anyway, so that's the contents I have today. And the next for the next slide, I'm just listing some of the resources that might be for help, and all the way from the SHAP's GitHub, SHAP paper, and the online book I mentioned for interpretable machine learning, and as well as online, which is considered as the first time to for interpretable machine learning, for introducing the idea of interpretable machine learning algorithm in 2017. Okay, yeah, that's wrap us up my today's talk. So yeah, so if there's any questions, I can probably address some of them.
Cool. Thanks a lot for the talk. So if you have any questions, feel free to type in the QA or ask in the chat. So the first one is which of the two shows a greater correlation? I can't recall which slide you have there, Chris, if you can recall. So there was like two things shows a correlation thing.
You mean the target dependence plot?
Christopher, if you can answer that, because it was asked during the presentation and I wasn't keep track of the slides.
Oh,
so
yeah,
I
sorry
didn't
about
really
that.
know. Yeah.
Can you repeat the question again?
Which of the two shows a greater correlation?
Well, so I found that the SHAP does a great job, not only because it's able to interpret the correlation, but it also provides the functionality to allow playing around the interactions between two features and seeing their interactions, the two interaction between the two features versus the target variable, and I find that it's quite interesting.
Cool. So seems like that's it. Do we have more questions? Feel free to ask in the channel or just speak up.
Okay, yeah. So if you want, I can go back to the slide.
Yeah, maybe if you could share it again.
Okay. Just 1 second. Sorry about that.
And meanwhile, if you haven't done so and would like to
Is this the slide you're referring to?
Oh. Christopher? Yeah, well, while we're waiting, I just want to say that if you haven't done so, put your name in the PyCharm draw. The link is in the general chat, so if you scroll up a bit, you can see it. and then yeah, we will do the draw later. So yeah, just if you haven't done so, please feel free to put your name there. And
Yeah. Anyways, so so if there's any other questions, so feel free to reach out to me via LinkedIn. So yeah, so you just search Chris Chen at Microsoft. So yeah, so I would love to answer any questions that you may have. Thanks so
totally.
much.
Yep, that's great. Thanks so much, Chris. Okay, yeah. Thanks so much, Chris, for this wonderful talk. And I have a bad news to announce. So I'm really, really sorry to announce that we had to cancel the second talk due to a time conflict. It was entirely my fault that there was a miscommunication in our organizing process, and I take full blame on this. I'll be extra careful next time and make sure this won't happen again. The second talk will be rescheduled, so keep an eye on the email and on our Meetup page. And again, I'm really, really sorry about it. It's been a bad job for me for sure. So I'll make sure this will never happen again. Yeah, sorry about that. Next, I guess we will do the live draw. So here is the link that I'm sending in the general chat. So if you haven't done so and would like to participate in the draw, please put your name there. It's going to be 2 draws, so 2 PyCharm, free PyCharm license.